but it's the job of a branch of the Air Force called Space Command to prepare for one. If you've never heard of Space Command, it's because most of what it does happens hundreds, even thousands of miles above. The research being done at the Starfire Optical Range in Albuquerque, New Mexico was kept secret for many years. And for a good reason, which only becomes apparent at night. First, the roof of one building is open to the stars. Then the walls retract, and an object straight out of Star Wars appears, shooting a laser into the sky. The laser's beam helps a high-powered telescope focus in on objects in space, so the Air Force can get a better look at the satellites of potential adversaries like China whizzing by at 17,000 miles per hour. It's part of a complex and mostly secret battle for what the military considers the ultimate high ground.
There is no such thing.
Visible missions is to make sure U.S. satellites can always get into space, from launch pads like this one at Vandenberg Air Force Base in California.
This is where space begins. If you can't get the satellite into space, it's worthless. I'm a satellite guy, so I get very nervous around rockets.
The Pentagon told us it spends $10 billion a year on space, but we found a White House report that estimates the real cost is much higher, $25 billion when you count spy satellites and other classified spending. That's more than NASA or any other space agency in the world. Some of those satellites provide the GPS signals that guide smart bombs now attacking ISIS targets in Iraq and Syria. But a lot of people don't realize those same GPS satellites provide the signals your smartphone uses to navigate. It's a service the Air Force provides free, not just here in the United States, but to the entire world.
This is a global utility.
In orbit, the satellite will spread out its solar panels, point its odd-looking antennas toward the Earth, and broadcast its location along with a time signal accurate to nanoseconds. A GPS receiver needs signals from 4 of these satellites to figure out its location. Colonel Cooley told us it costs $250 million to design and build each one.
And to put it in.
And a lot more than has 31 active GPS satellites in space right now, and a lot more than smart bombs and smartphones depend on them. Bank ATMs, cell phone towers, and power grids use their signals. Farmers use GPS to work their fields.
So at your active time, you're just going to go active.
The GPS satellite system the whole world relies on is operated out of this room at Schriever Air Force Base in Colorado. Conceal its location from attack.
So it can't hide in space. That's true. And in fact, it tells you where it is. This is a system the whole world depends on. Costs a small fortune to put it up there. And it's a sitting duck. Well, this is one of the challenges that in Space Command that we are very aware of.
Not just an anti-satellite weapon they're worried about. There are other dangers, too.
Today, we track about 23,000 objects.
How many of them are actually...
The movie Gravity dramatized the devastating effect man-made debris traveling at 17,000 miles per hour could have on the International Space Station. The JSPOC tracks dead satellites, old rocket boosters, even stray space gloves, and alerts satellite operators and astronauts if a collision is likely.
Last year.
A lot of the debris that's threatening the space station was created in 2007 when the Chinese tested a ground-based anti-satellite weapon. It crashed into one of their old weather satellites 530 miles above the Earth, shattering it into pieces.
This is the debris that resulted from the 2007.
U.S. doing it too? And did China recently raise the stakes, test firing a weapon deeper into space than ever before and threatening some of this country's most valuable satellites? That part of our story when we come back. It's safe from attack. But deep space is no longer the sanctuary it once was. A former Space Command officer told us that 2 years ago, the Chinese tested an anti-satellite weapon that went higher than any previously reported and came too close for comfort to the area where those missile warning satellites are located. One in 2007 actually hit a satellite and created debris, but one of the others soared to new heights.
There was one test.
To understand just how far that is, the International Space Station orbits at about 200 miles above the Earth. And those GPS satellites we showed you orbit at 12,000 miles. The 2013 test launch Whedon's talking about is believed to have gone up to 18,600 miles, just shy of what's known as geosynchronous or geostationary orbit. And that's where the U.S. military has stationed some of its most valuable missile warning sensors and top-secret communications devices that serve as its eyes and ears in time of war. I fitted testing an anti-satellite weapon in 2007, but China has denied conducting subsequent tests and told us it is committed to the peaceful use of outer space. It said the 2013 launch into deep space was simply a science experiment. It is making its new satellites more maneuverable to evade attack, and also more resistant to jamming. It's building a new radar system that will enable the Space Operations Center to track objects in space as small as a softball. And it's deployed 2 highly maneuverable surveillance satellites to keep watch on what other countries are doing high up in geostationary orbit. Satellite top secret. But Space Command put out this fact sheet about its new assets in geosynchronous orbit. Is in maneuver, right up close to the body of the rocket that had launched it into space.
So what is that
Kind of space race, a cosmic game of hide and seek. And the same technology that enables this telescope to see more clearly into space could potentially be used to help a laser weapon focus more powerfully on a target. The Bush administration wanted to develop such a weapon here in 2006, but ran into resistance from Congress, and that by most estimates spends 10 times more than they do, and has tested anti-satellite weapons of its own. Space Command told us an American F-15 fired a missile into space 5 times in the 1980s, and one of those times destroyed a U.S. satellite, creating debris that remained in space for decades. One of the officers involved in that test was General Hyten,